Next speaker is Mr. Jonas Berge, Senior Director of Emerson Automation Solutions in Singapore. Mr. Jonas is a trusted advisor for plants and EPCs to adopt new technologies, moving the industry forward with digital transformation. So let's welcome him to share on the topic OPC UA in process industry.
Imagine a data-driven plant, a plant that tells you or helps you ensure there are no surprise equipment failure, or make sure that there's no manual data collection required, or there's no hidden equipment fouling, and there are no undetected leaks or passing going on in the plant, or there's no surprise loss of containment due to corrosion, or there's no missing persons during the emergency evacuation, and there's no long waits for you to get the information, from lab sample test results. Okay, and really there are no surprise process upsets, that leads to unit trips. Okay, so this is really the vision for Industry 4.0 and digital transformation in the process industries, in process plants, like a refinery, like you see there in the background. And yes, these are very aspirational goals, but you need to set your targets high. So I'm going to speak about three things today. First, I'm going to start with a quick recap of the industry challenges, which is why plants need to change. Then I'm going to talk about digital transformation, which is really how plants are changing. And then lastly, I'm going to give some recommendations, for what plants need to do, like what plants are changing. Yeah. So I'm going to start with why. And it is really the state of the industry. Okay, so several industries, like oil and gas and metals and mining, even power generation, they are struggling right now and been a downward trend for a long time compared to many other industries. Okay, but even across all industries, they need to make some improvements. Okay, and really the reason for all of this, okay, is there's several disruptive forces going on in the industry right now. For instance, there is uncertain feedstock prices, there is unstable energy pricing, there's a shift in demographics, as older, experienced people are retiring, and at the same time, plants now need to attract, the young digital talent, and also retain this new generation of digital engineers. Okay, there is the energy transition, and there's also a demand, from the society for plants to become more sustainable, become more green type of plants. And lastly, now of course there is the pandemic lockdown, which to begin with has dramatically reduced the demand for many things, but also makes it difficult, for all of the people to work in the plant, as they need to maintain social distancing. It's also more difficult to bring outside contractors into the plant. So these are the main challenges which are going on. Okay, so to tackle all of these challenges, plants have to change. Okay, so they need to work differently. Okay, so really what plants are doing now, they're going towards remote fleet management methodologies. Okay, so they have maybe now a center, and from that center you actually manage multiple plants, across the country, the region, and even the world. Okay, so they manage the maintenance centrally, and it maybe even running the production centrally. Okay, depending on the industry. And they're also going for more autonomous operation. So basically no scheduled visits to remote locations, dramatically reducing travel and associated costs. Okay, more enabled work from home, because very often you cannot come to the plant. okay? And really going towards more data-driven ways of working, you know, where we have the prediction and detection of what's happening in the plant, okay? So we can decide what to do, okay? And lastly, well, really a lot of things are being automated, but for the things that cannot be automated, you know, like actual servicing of equipment, well, then we provide better digital tools, you know, for those tasks, you know, that cannot be automated. Okay, so really what the industry is looking for is new abilities, you know, to predict failure, detect fouling, losses and emissions, you know, to predict hazards in that plant and predict process upsets, okay? In order to do that, well, they need new capabilities, okay? So they need operational information on the go, wherever they are, you know, on their mobile devices, maybe as augmented reality, and yeah, they need this information on simple dashboards, okay? And to enable that, well, you need to detect and predict, you know, whatever problems and prescribe a solution, you know, which is done through that underlying analytics. And then below that, well, you need to have a data management platform that sends data where it needs to be, okay? And this is really where you're going to see later on that this is where OPC UA starts to come in, okay? And all of this is on a foundation of real-time data collection, you know, which is about automating repetitive manual tasks, such as collecting data the traditional way, okay? And then there's also the optimization and immersive learning, you know, such as through virtual reality. So really the goals of Industry 4.0 or digital transformation is to make the plant safer, to make the plant more sustainable, and to make the plant more human-centered, you know, to make it more convenient to work in that plant, you know, so that you don't have to go into the plant, you know, to get the data, or if you're in the plant, you don't have to return back into your office to get that information, okay? And these tools should be easy to use. You should not have to become a programmer. You should not have to become a data scientist to use these tools, okay? It should be possible to use these tools by the people which are already working in the plant, okay? We also want to become more agile, okay? So means an ability to adapt, you know, to shifting supply and shifting in demand. Yeah? And lastly, to become more resilient. Yeah? So these are the goals. So what's the value, well, of digital transformation and Industry 4.0? Well, it's relevant to every department within the plant, okay, doing the operations, okay? So for instance, the executives, you know, they are looking to reduce inventory, they're looking for that reduced legal liability and the overall plant life cycle cost, okay? If you look at the process and energy managers, well, they're looking to reduce emissions and carbon footprint, well, through reduced energy consumption, and all of that then also increases the sustainability of the plant. If you're looking at the safety HS&E department, well, they want to reduce the number of incidents. They want to reduce the cost of, let's say, cleaning up after incidents. The production department, and they are really looking to improve the throughput, increase the capacity of the plant. They want to become more flexible, meaning flexibility to handle different feedstocks, you know, different kinds of opportunity crudes, for instance, okay? They want to improve the yield of the plant and thereby also reducing the waste. Yet at the same time, not create any unnecessary quality giveaway, okay? And thereby, you know, also reducing operational cost by maybe less travel to remote sites and so on, and reduce the lead time for new types or new product grades, for instance, okay? And lastly, reliability and maintenance. They are looking to improve the availability, you know, and the asset utilization. They want to reduce the maintenance cost, extend the life of equipment, and yeah, ensure the overall integrity of the plant. So those are the values. Okay. So to meet these goals and realize this value, well, you need to transform. Okay. So digital transformation really means moving from manual and paper-based ways of working to new automatic, digital, software-based, and data-driven ways of working. Now, you can't do this in one single magic sweep. Okay. It is done with an agile approach, where multiple changes are carried out in rapid succession until you have holistically transformed your entire plant. Okay, and some of the enablers there you can see in the bottom is application frameworks and data management platforms, and that's where OPC UA comes in. So as an example, Emerson, we work with soil-based specialty chemicals in Singapore. Okay, so and it's a program that's been going on for some time and still continues until today. Okay, so and again, to make that happen, actually OPC UA was used to integrate a new digital technology with an old existing DCS that they have. Okay, because we need to get some of that data. And thereby we managed to reduce off-spec product in the plant. We reduced the downtime, we reduced their maintenance cost, and we also lowered their steam consumption. Okay, so you can read more about it in the article there. Just follow the QR code. Okay, so let me give you some recommendations here. Okay, the first one being decouple the level 4 business systems, the enterprise systems. So don't try to connect that too closely to your operational systems. Okay, they should be integrated yet separated. Okay, that becomes much lower cost to deploy and easier to support and secure in the long term as well. Make sure that you have the right data. Okay, many plants have lots of process data, but that's not enough. You also need to have equipment data. So you need integrate whatever subsystem and additional sensors. Okay, use modular apps. That applications, that can be added in to solve use cases. Or you can remove them if you don't need them, or update them, and even exchange them one by one as use cases gets discovered and get implemented. So don't buy one single monolithic software. That wouldn't work. Should be components. Use an agile methodology. Okay, so don't wait for and building an entirely new data management platform. Before you start the first use case. It's going to be very costly before you can show, and a long time before you can show any success. So start with the platform you have. Let's say like your historian. Okay, that is good enough, for the first couple of use cases. And then as the number of use cases grow, then you grow your data platform. Okay, and roll this out in sprints. Quickly do one use case after the other. Okay. Which is very easy if you use off-the-shelf software rather than trying to program yourself. So yeah, use ready-made applications. Okay, and roll this out in quick sprints. Yeah? Because apps, if you try to develop your own apps, it sounds like it's going to be better, but it's very difficult to state your requirements. So chances are that it's not going to be, it'll probably be less powerful than off-the-shelf software. Okay, so actually ready-made software tend to fit better. And make sure it's purpose-built. You can't use general purpose data analytics, in the process plant. The kind of software that is used, for credit card fraud or image recognition, is different from the software that's used to predict equipment problems. So use special purpose operational analytics. Okay, make sure that the software has been proven. If software has already been used by many other users, well then then you know it's going to work. You know, if it's custom-made software, well, then you are responsible for all of the testing. Again, if this is OPC UA software, well, then you know that all of the interface is going to work. You know, if it's software which is custom programmed API and custom programmed web services, you know, it becomes very too much and too difficult to test. Okay? And again, yeah, lastly, make sure it's standard spaced, okay? You can see that I put an OPC UA icon to many of these recommendations here, okay? And that is because OPC UA, you know, makes it very easy to integrate the right data. It makes it easy to have modular apps if those apps are based on OPC UA, okay? Because they become very easy to plug in and so on. So OPC UA is a key technology to easily roll out digital transformation. Right? So, and a few more recommendations for your digital journey here, okay? Start with a discovery session, okay? So make sure that you're solving real problems, okay? So you're not rolling out digital for the sake of digital, okay? So in such a workshop, you're gonna uncover many plant challenges. So prioritize those which are more important, you know, and which can give you a quick wins. Okay, for example, energy savings. The savings are very basically instantaneous, so you can quickly show a success and get, you know, more funding from the next round of use cases. Okay, build use cases. Okay, so think about how much are these losses costing you. For example, steam trap failure. How much steam are you losing? Pump failure, how much production downtime and production loss is that causing, you know, and heat exchanger fouling, you know, causing slowdown, how much is that costing you? Okay, so this is really the economic justification for digital transformation. Okay, use ready-made apps, you know, which are built on OPC UA, you know. Don't get a consultant integrator to charge you a lot of money to custom-made software that does something which is already existing. Okay, use proven solutions. Again, that's all solutions proven by other users. You know, so you don't have to do the testing. Okay, again with OPC UA, that's very easy. Lastly, rewrite your standard operating procedures. That's the whole purpose of digital transformation, is to change the way you work, you know, to use the software first. Look at that data, be data driven, okay? So make sure that's reflected in your procedures, okay? So, and all these ready-made enablers already exist, okay, and very much based on OPC UA, okay? So you can get that user interface at the top, you know, on your mobile devices, on your desktop, your laptop, and even on your video walls, okay? But that information, you know, it comes from the operational analytics, you know, which allows you to detect and predict, okay? And that analytics in turn gets its data from the data management platform, you know, that ensures that the data goes to where it needs to be. And perhaps that's really the heart where OPC UA really sits, okay? But all of that software really rests on a foundation of data and automatic data collection. So there's a lot of additional sensors that are going to be required in your plant, okay? And yeah, well, digital twin can also be there. I do want to stress that not every use case needs a digital twin. In fact, very few use cases need a digital twin. You might use a digital twin for process modeling and simulation and for virtual reality, but things like predicting equipment problems or monitoring equipment efficiency, many of these things don't need to have a digital twin. Okay. Okay, then and then lastly, yeah, build on an open platform like the Namur open architecture, right? Because it provides and also use a digital operational infrastructure built on OPC UA. Okay, yeah. So some detailed recommendation. Okay, about the Namur open architecture. The beauty of this architecture, okay, is that it leaves the DCS, you know, the gray part that remains unchanged, okay? So the DCS that you have, it remains as is, okay? And then it's really, that makes sure that we are not upsetting the integrity, okay? So the sensors and software is not installed on your existing DCS. Instead, you add a second layer in automation there in pink. That's where the additional sensors, wireless sensors are connected, all of the additional analytics apps, okay? And as you can see in that diagram, OPC UA is at the very heart of the Namur open architecture standard, known as NE 175. Okay, and then modular apps. Okay, and again, lastly, decouple the operational systems here from the business systems. Don't make them too closely coupled. Okay. So when it comes to that, to the top layer, which is presentation and visualization, these are some functionality or features that you may want to look for, that you should be able to create personal KPI reports, okay? Because the plant manager, the maintenance manager, they need different information from, let's say, the energy manager or the integrity manager, okay? Similarly, personalized real-time dashboards, okay? Because then the reliability and manager, again, need other information different from the safety manager or whatever. You get the picture. Same thing, personalized mobile notification. Everybody in the plant cannot get all of the alarms, right? You would go crazy. You only need to should only receive the notifications which are relevant to you, okay? And integration with your ERP system, okay? So there should be a loose coupling with the ERP system, such that you get that closed loop maintenance. So when the analytics predicts a problem with the equipment like a pump, then that goes into the CMMS system, to trigger a work order for somebody to actually fix the problem that was predicted. And augmented reality also plays in here so that it becomes easy to find that piece of equipment within the plant. Digital worker means instead of having a paper notebook, you use your smartphone, and if you spot something which is not right in the plant, you take a photo of it with your smartphone or tablet, and of course these are available in hazardous area version, that can be used within in a plant. Operational analytics, that's different from business type of analytics. Okay, so operational analytics, that is equipment condition monitoring, performance monitoring, integrity monitoring, meaning corrosion. It means energy management, process prediction, and so on. Okay, so functionality that you're looking for here, okay, is it should be predictive. So it tells you in advance before the equipment fails. And it should be descriptive. Shouldn't tell you just this anomaly. It should specifically tell you what the problem is. And prescriptive, provide a recommended action. Okay. Again, there should be ready-made apps. There are so many ready-made apps available already. For control valves, steam traps, pumps, heat exchangers, cooling towers, etc. You don't need to develop all of this. Thanks to OPC UA, all of these kind of plug into your OPC UA framework. So use those ready-made, purpose-built analytics, and they are built on first principles and FMEA. Okay, so you don't have to be an expert in artificial intelligence or machine learning to make that happen. So really the key to bring all of this together is the data management platform, which then needs to support OPC UA so that you can aggregate the data from all of your various data sources in the plant, okay? It should also contextualize this so that the information is grouped together logically, so it becomes easy to use that information. Obviously, it stores the data, but then it also then shares the data to all of the different apps. So both the aggregation and the sharing is through OPC UA. So, well, the data comes from additional sensors, existing sensors, but also many additional sensors are required. And in fact, a plant might need hundreds or even 1,000 additional sensors. You can't practically wire all of these additional sensors, so that's where wireless comes in, okay? So again, technology selection is important. Make sure there's lots of different wireless technologies out there for sensors, but make sure to use one which is an IEC standard, has 99% reliability, supports real time. 1 minute or 1 hour is good enough for many cases, but sometimes you need 1 second, or a few seconds. So you should support that too. Provide long battery life, like 10 years, so that battery replacement doesn't become a burden. Very important. The gateway must support OPC UA so that you can bring this data into your, to your new analytics apps, but also to your existing control system. All of this should be industrial grade, and should also be non-intrusive, so you can easily install these sensors, cutting, no drilling, no welding. Okay, and of course, since it's wireless, no power cord, no signal wires. Okay? Modeling and simulation, I don't think we really have much time for that, but again, yeah, a digital twin, not used for many use cases, but yeah, if you want to do, virtual reality, you would need a digital twin with process model and also a 3D model of your plant. Okay, so how does all of this come together? So at the very top, yeah, you want to have dashboards, you want to have notifications on your mobile. Okay, that's the top layer, and all of that information comes from the application framework. That's where all of the analytics sits. That in turn gets their data from the data management platform. That's really where OPC UA lives, as the interface between all of these different software. Okay, and all of this rests on a foundation of sensors. Some of the sensors in your existing systems, some of them are new additional sensors. So conclusion, I spoke about three things. First, the industry challenge, many industries are struggling, which is why plants are changing. Then I spoke about how plants are changing through digital transformation of how the plant is run and maintained. And lastly, I spoke about what plants are changing, gave a couple of recommendations very much around OPC UA for how plants can adopt Industry 4.0 to tackle these challenges. So in summary, I spoke about the why, the how, and the what of digital transformation. Okay, so that's the presentation. These are my contact details, So over to Yape for, well, if we've got time for some questions. Yeah.
Yes, thank you, Jonas. I think we have time for probably one or two questions.
Great. Yeah.
Okay, I have one here from the audience. Okay, you mentioned about don't reinvent the wheel. What does it mean to use standard ready-made products? What if my system integrator has a better solution? What should my stand be as an end user?
Well, if your system integrator has a ready-made off-the-shelf software that is better, well, then that's good. I mean, then you're not reinventing the wheel if they already have that product. Okay. However, if they need to write, or believe that they can write custom code software which is better, chances are that they are delusional. Okay. Because it happens all of the time that system integrator thinks that, oh, to monitor a heat exchanger is very easy. When I studied chemistry back in university, all of the equations were in the handbook, but that's only the very beginning. Okay, so to go from the heat transfer coefficient calculation to a ready-made heat exchanger analytics it's much more than they could possibly imagine, and for them to do that, also, you as a user, you will have to write the list of all of the features that you have. And that is very difficult, Think about a software like Word, okay? If you want to write down all of the features in Word that you are using, it will become a very long list, and yet you will forget half of the things, okay? So now what happens is when your specification is not good, well, the software that the developer creates is no good. Okay, and to fix that later on is going to cost more, and it's going to take longer, and it's going to be iterations of testing. It's going to take forever. And then when that software person leaves your company, or the integrator closes shop, now you are trapped with the software that only they understand. Okay, so using custom software should really be the very last resort. And I mean, there are so many articles out there. You can simply Google the debate on ready-made versus custom-made software in general.
Okay.
Mm-hmm.
Thank you for your time. I think that's all the time we have for today.